going.
Okay.
Okay, yep, we're good
All
to
right.
go. So last one, parrot's feather, top right. This one is also not super common in the West Coast, but it is around, so we're also on the lookout for it. Okay, next slide.
All right, next we're going to get into floating leaf plants and kind of just do a rough overview of them. This thing goes perfect. Top left, we have fragrant water lily or white water lily. Your top left, yes. And it's kind of similar to your other lily, our nufars, which are right below it, but basically it has more of a heart-shaped cordate leaf on the bottom of it. The white water lily is going to be completely circular, and then the leaf margins are going to come and kind of make like a piece of pie in the middle. Middle, we have our duckweed, Lemna minor, common floating leaf plant, very small. Basically, they're like little water clovers that just kind of float around. Then we're going to have top right, yellow water lily, common, see it a lot. And then we're going to have water shield, bottom right. So in the picture right here, these are the water shields right here. And then you have that white leaf, which is your white water lily.
All right, emergent vegetation. Here's one of our ex-employees driving around an airboat doing some emergent noxious weed control.
It's not going there.
Oh, it's not going. Okay. I just can't get it to share. I think we shared the wrong screen. I think we got to go.
Go back, do it again, share that one. Yes.
This is the one that was working last time.
Okay. And then see if you can skip through it. Okay.
There we go.
All right, emergent vegetation. Here's one of our employees on an airboat. All right, next. So cattails and bulrush. These are native plants. Sometimes they grow noxiously. Sometimes people do mechanical removal projects to control them. Let's see. Okay, so this is some of the invasive emergent vegetation we've got growing around here. So the top left, below that is Phragmites. Top right is garden loosestrife. And then this one right here, middle right, that's purple loosestrife. And then a big invader, especially on the Pondere River and in the Columbia River system in general, is flowering rush, something we're trying to fight more often here. And it's becoming more of a problem.
All right, next we're going to get into herbicide technologies. Now that everybody's an expert in terrestrial and emergent vegetation, we're going to figure out how to kill it. So here's some important glossary terms that you're going to need that are going to be pertinent to kind of understanding the rest of the talk. We have algicides versus herbicides. Herbicides usually for broadleaf vascular rooted aquatic plants, and algicides, you're going after planktonic or filamentous algae. Contact versus systemic herbicides. A contact herbicide is basically like chemical mowing, and you're going to be able to take down the plant for that season, but it's not going to translocate to the roots, and it's not going to give you multi-year control. A systemic herbicide generally takes longer to work, but to kind of grow through the plant. But once it's grown through the plant, that plant's dead forever. We have granular versus liquid. We have granular herbicides. It's a pellet form. You put it out in a spreader, it usually sinks to the bottom. These are good for areas of high water exchange where you're worried about losing concentration due to movement. And then we got liquid. So yeah, it is what it is. It's a liquid. Surfactants, stuff like methylated seed oil. These are things that help penetrate plant tissue. And then also, they can also be stickers. So let's say you want to spray lilies and your herbicide might run off and you can put a sticker on there. So it's going to kind of get held on the plant so it can have enough contact exposure time to kill. And then water use restrictions. Every one of these chemicals are US EPA approved, and they have water use restrictions for irrigation, drinking, and swimming for all of them. Some of them don't have them, but all of them have guidelines to, how long you have to wait to use the water or things like that.
All right, we're going to talk a little bit for a while on Eurasian water milfoil control. It's the main thing we do around here in the inland Northwest. So here's some control options that we had before 2019. So we have contact herbicides. These provide short-term relief. Again, they chemically mow it, so it'll come back again next year, but it gives you instant relief. And then we have systemic herbicides such as 2,4-D and triclopyr, which provided longer-term control as systemic herbicides that killed the root crowns, But we started to see lots of hybrid plants showing up in the Pacific Northwest. The native northern milfoils were hybridizing with the Eurasian invasive plants to kind of create a super strain. And the 2,4-D was starting to lose its efficacy. So there was a need for better technology for herbicides. Also, we can gain long-term control with sonar, which is fluoridone, but it requires a whole lake treatment and at least a large area to gain a contact exposure time. So it's not as good an option.
Boom. 2018 US EPA approval of ProcellaCOR, or fluoropyroxafen benzyl. It's the first new herbicide active ingredient in 30 years to be registered just for aquatic use. So generally when you go in the big ag world, when you go make a herbicide, it's usually meant for, doing stuff on farms, or is generally not, designed for just aquatics. But ProcellaCOR was made just to be aquatically labeled. You can't use it terrestrially. Yeah, basically it's highly selective. It has a short exposure time, so hours to days. It enters the plant tissue and then begins working. It's good in high water exchange environments, so it gets into the plant tissue quickly. So if you want to treat a reservoir or a river or something where the water's flowing, it's going to be able to get into that plant tissue before the dilution of the water moving kind of brings it out of there. EPA reduced risk classification. So you can use very small amounts of product with this. So basically, I know maybe like 12 to 15 ounces of this herbicide will replace like a couple 100 pounds of a traditional granular herbicide. So as far as applicators, your risk for exposure is greatly reduced using this. Yeah, that looks good. Okay, so here's a mesocosm study at the Aquatic Plant Control Research Center in Texas. And basically we have our milfoil in this trough on the bottom left, top right American pondweed, and then we got another native top left. I can't tell what it is from the top. So basically this is 3 parts per billion at 6 hours exposure, 2 months after, and we can see our native American pondweed, and I think the other one actually might be Elodia, but the milfoil is completely wiped out. So basically with this herbicide, we're trying to do underwater forestry, and we want to keep the natives, because if you go and use a contact herbicide that just burns everything off, invasives are disturbed site plants. So the first thing that's going to come back is probably that invasive, unless you can just target your invasive plant.
All right, so this is the plant concentration factor graph. It's kind of a lot going on, but basically it shows that the herbicide is uptaken, which is ProcellaCOR, by the plant way faster than the other herbicides that we used to have. So after 30 minutes, you can see it's already 20 to 30% uptaken. And, the other herbicides, 2,4-D and Aquathol, they haven't even gotten to 5% yet. And then if you bust over here to 129 hours, it's already 100% uptaken, whereas the 2,4-D is only 28.4%. So it's got a very fast uptake time.
Yep.
All right, so applying ProcellaCOR, it's kind of got a special dosing unit. They came up with their own prescription dose unit, which is basically, they took a page out of the pharmacy books to come up with their own dosing unit. And it's kind of complicated figuring out how much you need to use, but it's variable by the size of the plot, size of the lake, water exchange properties, if it's Eurasian or if it's hybrid, or in how deep the plot is. So coming up with costs, it's hard to just say a number because, well, you got to go out and analyze the lake first before you figure out how much you need to use and how much it's going to cost.
All right, so here's just a run over the projects that we've been involved with the ProcellaCOR in the Pacific Northwest since registration. We got Morton Slough and the Pondray River. We got Loon Lake, Liberty Lake, Newman Lake, Sasheen Lake, Lake of Soyuz, Noxon Reservoir, American Lake, Hayden Lake, and Vancouver Lake. We have 90 slides, so we have to go a little faster.
So the first treatment of ProcellaCOR in the Pacific Northwest, this occurred before it was registered. It was a research trial. And this occurred on Morton Slough up in Lake Pondray, just over the border up in Bonner County. They selected 3.5 acres for treatment. They hit it with high rates, which is 5 PDUs per acre foot. And the treatment occurred in 2018 in August, and it proved highly successful. This is our research crew that's out there doing the testing and first treatment. All right, so now we're going to talk about our Loon Lake hybrid milfoil study. So Loon Lake is a 1,200 acre lake located north of Spokane, about 45 minutes. It's got about 200 or 300 acres of littoral zone. They've been doing Eurasian water milfoil treatments probably through about 1990. We've worked through them about 2007. And then they were treating it with Diaquat 2,4-D tank mix after 2007. It wasn't working that great. So the Lake Association, they issued a new RFP and they wanted someone to develop a proposal and a program using triclopyr to treat their Eurasian water milfoil. But we decided to test the milfoil and we showed that it was hybrid. So what they did was they decided to establish a lake management district. Basically what this means is that they can fairly tax everyone on the lake legally and put it into a big fund for management issues and other things that they need to use the fund for. They also tapped into the Department of Ecology Freshwater Aquatic Plant Fund, which is funded via boat trailer fees. And they were able to get about 100K to do management through these different grants and the Lake Management District. So we set up a study. First, we mapped the infestation. We collected plants from target areas. We performed DNA analysis, and we shipped these plants to North Carolina State University. And they decided to do some contact exposure experiments to see how the herbicides would affect it over time. We developed a treatment recommendation specific for this population and developed treatment protocols for ProcellaCOR and for triclopyr. The first operational treatment was with ProcellaCOR, and that occurred in July 2019. We were able to write a manual for targeting hybrid populations. All right, so here's our first treatment out on Loon Lake in 2019. It occurred on July 9th, targeted 75 acres. Here's the treatment map. There was many different depth zones. So we did some areas that were 3 PDUs and some that were 6 PDU per acre foot. And we were able to get a good post-treatment sampling and did a follow-up survey to see our results. And here's some pictures from us applying it as well. We're laying down lines in the left photo, and here's me and my associate treating around docks.
So point intercept grid survey, this is what we did to kind of evaluate the efficacy of the ProcellaCOR. So basically you can see all these little red dots inside the plots. Each one of those areas is you get on your GPS, you throw a rake out, you pull the rake in, and then you see if you catch any milfoil basically. So I could read off this slide and read the whole thing, but I'm not gonna. 1 year post-treatment basically just shown that we had no milfoil observed in any of the grids on any of the 52 locations that we were throwing the rake. So 1 year post-treatment, no milfoil present. This is Loon Lake milfoil management in 2022. Sorry, we don't have the 2023 slide, but we're still doing it. ProcellaCOR treatments have occurred every year since 2019. A pre and post-treatment survey has been beneficial for us to get geared up to kind of know where our plots are going to be the next year. Annual treatment acreage has decreased from 75 acres to approximately 22 acres in 2022. So if you're doing this kind of work right, you shouldn't be treating more every year. You should really be dwindling it down. And everybody likes to use the word eradicate, and it's like, that's never going to happen. You're going to chase this stuff around for years and basically get it down to where it costs maybe a fifth of what it cost initially. And then you just kind of isolate your problem and chase it around. Yeah, so we've mostly consisting of smaller treatment zones. So this is the treatment map right here from the last year. You can see we're not treating the whole shoreline. We're kind of just finding it in certain areas and dosing it. We've observed native submerged vegetation such as water marigold rebound almost too good. It's kind of causing the homeowners some problems, but it's not milfoil and I'm not hard to kill it, so it doesn't matter. Next. Eurasian water milfoil management at Liberty Lake. First usage of ProcellaCOR in Liberty Lake occurred in 2022. We treated approximately 13 acres. Eurasian water milfoil is primarily observed most densely along the southwestern shoreline, and other treatment zones were more spot treatments due to lower distribution. We actually went and surveyed this yesterday, and There's probably around 5 or 6 acres, so we kind of dwindled it down by half.
All right, Newman Lake. This is another lake that we used ProcellaCOR for the first time last year, and we treated approximately 23 acres. The highest density was found in the northern shoreline. There was other high density areas that we targeted as well. They had a limited budget, so we basically chose to target the most high dense areas, and we're just going to keep chipping away every single year on different infestations around the lake to bring the numbers down. And we just surveyed this lake, and the numbers already look better from last year. We haven't done the treatment yet this year, but yeah, we've basically reduced some of these areas that we treated last year, and we're moving on to the next area of dense growth that wasn't treated the year before.
Here's your water milfoil management at Sasheen. Here's kind of just like a brief history of the last 30 years. In the 1990s, our company conducted a full lake fluoridone treatment, which dropped EWM to very low levels of detection for about a decade. In the mid-2000s, upstream EWM sources started to recolonize the lake, causing the milfoil to go back to nuisance levels. Trickle pure treatments occurred almost every year to keep the EWM managed. The district took a few years off treatment in the late 2010s, which caused the EWM to create a monoculture once again. Upon the registration of ProcellaCOR and ample funding from the district, we commenced our first ProcellaCOR application in the lake in 2020. So here's just kind of 2020 to 2022. This is kind of a success story as far as, lake management goes with milfoil. But as you can see, we have how many acres? 44 in 2020. And then we got that down to about 3 the next, 2 years later. So instead of it costing, whatever it was, maybe $70,000, you get it down to like $3,000 or $4,000.
Okanagan chain of lakes. So there are a series of lakes that extend up into Canada. And there is one particular lake called Lake Osoyoos. It's in Okanagan County, and it's half in Canada, half in America. We used ProcellaCOR in the lake for the first time last year. We treated 64 acres on the east shoreline, and contact herbicides were treated on the other side of the lake. We were very interested to see how the contact herbicides worked 1 year post-treatment versus the ProcellaCOR. And we did come back and do a analysis on a post-treatment survey, and I'll show you the photos for that in a minute. But we plan to treat this lake again this year, and we're going to be treating the west side. And there was lots of milfoil left on the west side because they only use contact herbicides over there. Another thing of note is that Canada has officially registered ProcellaCOR. So we were able to, before in the past, we couldn't treat within a quarter mile of the border, but now we can because ProcellaCOR is registered up north. So we're treating right up to the border where there's dense milfoil, and we're going to treat approximately 35 acres this year. Here's our pre and post treatment photos that we took last year in the ProcellaCOR zones. So as you can see, the first photo, pre-treatment, dense, long milfoil. And then we came back about a month or 2 after treatment, and all the milfoil was dead or dying. And yeah, it looks really good. So yeah, as I said, it's going to be approved in Canada, or has already been registered in Canada as of last month. So we're interested in doing some research trials for the Canadian government. There's a lot of lakes that are up on the Okanagan River, a chain of lakes that go way up into Canada. All are choked with milfoil, so we're interested in fighting it up there in the coming years.
So American Lake, here's another case study on the west side for ProcellaCOR. Eurasian water milfoil problem. This is a 1,200 acre lake. They let out an IAVAMP, or integrated aquatic planning management grant. They always make these names so they roll right off the tongue. Treatment of 166 acres of ProcellaCOR in 2019. We had excellent results. So basically, we treated the whole littoral zone. So this is kind of the treatment zone. And as you can see, anywhere that it was less than about 6 feet, we treated. So here's a really good slide, but this is just a picture from the boat ramp pre-treatment. So as you can see, topped out monoculture milfoil on the left of the screen. On the right of the screen, 1 year post-treatment, there's no milfoil on its rocks like it's supposed to be. So a lot of people with this kind of work think that it's invasive towards fish, but it's actually improving spawning habitat a lot of the times. Salmon and trout do not spawn in topped out milfoil. And actually, if you took a DO meter and you stuck it in those monocultures, the DO is 0. So no fish can even live in there. There's no water exchange in there. It's usually a lot hotter. So when you're doing this, you're restoring basically spawning habitat half the time for salmonids.
All right, so the first treatment that was done in Montana was up on the Noxon Reservoir. This is the input to Lake Pend Oreille. And we targeted 34 acres, and this was done in 2019. And they did it at a high rate at 5 PDUs per acre foot. And here is the pre and post treatment surveys. So as you can see, pre-treatment, high density milfoil found, and then post treatment, there was a 93% reduction in Eurasian water milfoil. We also did a bio-based survey where we used sonar to scan the vegetation index of the bottom. And as you can see, there's high dense outside the plot, and inside the plot, there's very low dense milfoil found. Here's just another little chart that shows the presence of Eurasian water milfoil. I was up to 98% pre-treatment, and we got it down to 5% post-treatment. And the other native plants are starting to rebound, such as Elodea and other pondweeds that are native. Basically, the main thing, this is kind of a long quote, but the main thing about this treatment was that it proved that you can use ProcellaCOR in somewhat moving water. This was done in a run-of-the-river reservoir, and it proved that you can gain a long enough contact exposure time for it to work on Eurasian water milfoil in moving reservoirs.
Here's just a slide, Hayden Lake, Idaho, ProcellaCOR 2019. I'm sure everybody's familiar with this place. 6,800 acre lake north of Coeur d'Alene. We treated 93 acres. Treatment plots varied from large enclosed bays to narrow, steep shorelines. So we were kind of messing around with it here to see where it would work. Would it only work in the bay? Would it work in the steep shoreline? And it kind of proved to work everywhere we used it. These treatments were performed for Idaho Department of Agriculture and evaluated by ISDA in the summer of 2020. And here's just a testimonial, kind of like we had with FWP, where they went and surveyed 215 points in a point intercept grid survey kind of thing, and they weren't able to find it at any of the points.
All right, another quick lake, Coquilala Lake. This is another 700 acre lake just south of Sandpoint up in North Idaho. We treated 50 acres in 2019, and it was evaluated by the Idaho State Department of Agriculture next year in 2020. And they found no traces of Eurasian water milfoil in the whole lake, which is another success there.
Vancouver Lake, Washington, 2,700 acre lake connected to the Columbia, tidal influence, heavy EWM problem, and it generates a lot of socioeconomic money from the regattas, about $2 million locally. So there's a need for the water not to be obstructed to make that money. Treated July of 2020, we utilized 3 application boats, treated 700 acres in the main lake, 15 acres in the flushing channel, as you can see on the map. And the project took about a day and a half to do. So post-treatment survey, it was evaluated, 700 acres post-treatment results at the end of the season, no EWM found by WDFW staff. So ProcellaCOR summary, not that we haven't talked about it enough. It's an excellent tool for selective EWM and hybrid milfoil control, has a fast plant accumulation time that allows for use in high water exchange environments, has a good environmental tox profile, no water use restrictions, except for a manageable 24-hour irrigation advisory for turf and ornamental. So if you got a bonsai tree, maybe they didn't test that on that, but just about everything else tested it on before they made the label. Easy to use, 200 PDU container that can replace thousands of pounds of traditional granular herbicides. They're a little more archaic.
All right, we're going to talk about another invader. This time we're going to talk about curlyleaf pondweed. So curlyleaf pondweed, it's started to increase its range in the past decade or two. It started to show up a lot more in lakes around the Pacific Northwest. It has quite a unique life cycle. It's not really like any of the other submerged plants found around the West Coast. it begins to grow under the ice long before the other submerged plants begin to emerge and germinate for the season. It hits full bloom in the late spring and early summer, and then it begins to die back by the mid to late summer period. It spreads via seeds known as turions, which begin to fall off the plants usually around June or early July. Here's a chart that shows the life cycle. As you can see, the seeds are being deposited in the fall, and then when the ice comes on, they start to germinate, and then they're just very small plants underneath the ice. And then once the ice is off and it starts warming up, they just sprout right up in the spring, and they're at the surface, by the late spring and early summer, they're fully going, and then they're starting to drop their turions early summer. This is the optimal time to control it because we're trying to reduce the seed bank as it's at its full growth period. And then it drops off and it dies before all the other plants die, usually midsummer, and starts the process over again.
Treatment options for curly pondweed. For contact herbicides, we have aquathol and diquat. Aquathol, that's just a trade name. It's dipotassium salts. And then we have systemic herbicide sonar, contact exposure time requirement. You have to hold you're going to have to treat a big area, and you're going to have to hold a contact for, probably a month to actually get into the plant, which also when you do a sonar treatment, you have to make a fluoridone management plan for the DOE. So it's kind of a whole bag of worms. And now we have ProcellaCOR, so nobody does that anymore. Then we have Gallium. That's a new reduced risk herbicide. What's the active on that? Penoxylum. Yeah, we've been kind of messing around with that too. What we found is high water exchange environments isn't great. Really, if you have an enclosed bay or an area where there's not much water movement, it can work for that. But it's cool because it stops turion production within a few hours if it's held at the right concentration. So you're killing the viable, plant material that's going to propagate to make new plants, which is a good tool in management. Here's our galleon. Basically, we just got a nice confusing graph right here that we don't have to talk about too much, but we have parts per billion on our y-axis. On our x-axis, we have our treatment plot. So basically, the only thing where you got to get from this is as you treat larger areas, you can use a smaller concentration to control it. Pond Ray River treatments for private homeowners in the Box Canyon Reservoir. Contact herbicides used in a blend with long drop hoses. We've seen good results. Basically just treating shorelines, people's houses, and chemically mowing it.
Yeah, there's one thing I want to say also to that. We go back
to it.
So yeah, most people think that they have milfoil, but usually they have every kind of plant, native plants, milfoil, curlyleaf pondweed. That's why we recommend just doing a contact herbicide blend, because it'll just knock everything back. You just want total nuisance plant control. So yeah, most of the time you have every kind of plant up on the river. If you someone who lives up on the Pond Ray River. So next I want to talk about irrigation water treatment. So my favorite herbicide to use if you're treating in an irrigation pond or lake is Aquathol K. This is an endothol. That's the active ingredient. There's no irrigation restriction. Also, you could use a copper herbicide such as Comine, Nautique, or Descend. They're copper based, so they don't have irrigation restrictions. You can use sonar in some conditions. But you got to hold a longer contact exposure time. So it's harder to treat with it sometimes.
Okay, emergent vegetation treatment options. We have Clearcast or Amizomox, excellent on all emergent plants. It doesn't have much water use restrictions. It's really safe and you can use low rates. So we've had good success with that. Glyphosate remains one of the cheapest, best solutions for emergent control. It's a systemic herbicide. It's cheap. It's easy to use. You need to include an aquatic surfactant if you're going to be doing this kind of emergent spraying. Otherwise, generally your chemical is just going to kind of slip off the leaf and it's not going to penetrate and work. So a competitor or an aqua sticker or something like that is usually good to use. And these herbicides also work excellent on floating vegetation.
All right, we're going to shift gears and talk a little bit about algae. Let's save it to the end.
Yeah.
So first, first type of algae is a planktonic algae. So these are single-celled plants. Basically, they're plants, but they're single-celled. And planktonic algae is suspended in the water column. So this can consist of green algae, diatoms, cyanobacteria, which is our toxic algae that we're worried about mostly. And the biggest defining factor of planktonic algae is they can regulate their position in the water column.
All right, golden algae or chrysophytes, first noticed in Texas and it's native to Scandinavia. It's spread across the east coast of Florida and west of Arizona and California. It produces toxins that stop oxygen transfer across the gills of fish. So like this picture you see right here in the middle, those are all dead fish. You know when you got it because every fish in the pond dies overnight. And it can come on rapidly, often first you know is when you have dead fish. Maybe you.
All right, next kind of algae, filamentous. This is when you see the mats usually. Basically, the algae mats, the filamentous, it'll create a mat on the lake bottom, and then it'll start to lift once the gases are produced, usually when it starts to get a little bit hotter. And this is when you really start to notice it, is when it's on the surface of the water. Some can secrete mucus that protects the cells from algicides. But yeah, this filamentous algae is when it creates the mat on the surface.
All right, macroalgae is commonly mistaken for aquatic plants, but they're really actually algae. So there's Chara, Nitella. It can be treated with a herbicide with no results. So basically, a copper mixed with this and a diquat is going to probably work best. Muskgrass is the common name. So if you squeeze it in between your fingers, it'll have like a little musky odor, and you can actually feel the cells pop when you close it because it's single celled. So that's how you can kind of tell what it is. Generally has calcium buildup on the plant tissue, so it'll have like kind of a white hue looking on it. And it's actually not that bad of a problem to have because it only grows about 6 inches to 8 inches off the bottom, so it's never going to top out and cause a bunch of problems, and it takes up nutrients. So golf course ponds, stuff like that, it's actually kind of good to have in lieu of other things.
All right, now let's talk a little bit about harmful algae blooms. I talked a little bit about cyanobacteria, and that's basically what causes the harmful algae blooms, also known as HABs. Here's just a silly slide that our boss made. Was on a Verizon advertisement. You can see the Washington Monument. The reflecting pool's got algae in it. So it's a common problem throughout the country. So basically, harmful algae blooms, they can produce acute toxins, liver toxins, nervous system toxins. They can produce chronic toxins in waterfowl. They have potential human health impacts. This is a picture up on Lake Erie near Ohio, near a potable water intake, which is not good because cyanobacteria, which are HABs, are potentially hazardous to human health. Also, it's been proven that HABs have a direct link to ALS, and also you can get exposure from airborne toxins. So if you're nearby the HAB, you could potentially be exposed to it just from the air. And also exposure can come from potable water supply if you're drawing water out of the reservoir for drinking, which could potentially also be hazardous as well.
All right, now that we know about HABs, let's talk about how to treat them. Reactive HAB treatments. So US EPA registered algicides can be used to provide relief. Copper in the state of Washington is illegal because salmonid's everywhere. So permit issues, peroxide can be used in permitted waters. It's basically just a granular hydrogen peroxide oxidizer, but really, really high use rates, and it's kind of nasty to touch. First picture is the city of Maple Valley Ironman event. Toxic algae blooms happening right here, was going to stop the event, so we came and treated it, and then everybody went and swam through the pond and they were fine. And then on the right, this is us in Utah Lake doing a peroxide algicide treatment for a state park.
All right, that was reactive treatments. Now I'm going to talk about some proactive treatments, which is basically sequestering nutrients and inactivating it. So major nutrient we're worried about, phosphorus. Phosphorus is very critical to managing eutrophication. As you can see by this graph right here, as you go up in total phosphorus, it just encourages more cyanobacteria algae species to grow rather than the good beneficial green algae that we'd rather have in our lake than the toxic algae. There's a lot more you could talk about that, but that's just a basic thing. High phosphorus means potentially you could get toxic algae.
Aluminum sulfate, this is another kind of more reactive-ish kind of treatment. So basically, it's also called alum. You go out. 2010 Southern California operations, we began annual management contract for 9 regional parks and 15 lakes in SoCal. Highly eutrophic, park of highest concern receives reclaimed water half the year. Alum performance in high pH water was an issue, so we had to find an alternative. This is you. Okay, alum and phosphorus capture. It's not effective in high pH waters. SoCal lakes with cyanobacteria blooms can have pH in that range and can be problematic. So we needed to find a better technology. We got Utrisorb G. I think this is me. Oh, here you go.
So we got Utrisorb G, which is a lanthanum product. And so we like to use Utrisorb rather than alum because the Utrisorb, which is lanthanum, it captures the free reactive phosphorus permanently, and it makes it so it's biologically unavailable. And also the water quality is not impacted from the phosphorus sequestration. When you're doing alum, you can risk having a large fish kill because it'll alter the pH, and you got to be kind of careful. Sometimes you have to use a buffer to alter this. But as you can see from this this graphic right here, the Utrisorb falls through the water column and it binds with the phosphorus as it's falling through, and then it creates a layer on the bottom and binds the sediment phosphorus, which is what we're really worried about as it's getting released throughout the year. Could talk more about that, but that's a little basic about Utrisorb.
All right, nice case study here on the west side, Kitsap Lake, Washington. Here's a picture of it. Pea soup green. It's a 245-acre lake west of Seattle. It's had toxic algae closures for several years. So basically, the WDFW comes there and they test. They find cyanotoxins. Nobody can go swimming. They issued an RFP for phosphorus management plan in 2019. We competed and were selected. After community input, the program was implemented in the summer of 2020, and lanthanum, which is a rare earth metal with a bentonite clay matrix, was selected as the primary tool for management. So first treatment week of June 10th, 2020. Here's just pictures of the skid steer loading the product on the boat. Yeah, this is kind of our big barge, just kind of spraying it out of boom busters off the back. As you can see, it's kind of the flock in the water column from the other transect that we were running there. Project operations, 2020, first year of treatment, June treatment targeted water column phosphorus. So as it's moving through the water column, you're trying to flock out that phosphorus and sediment it. And then August treatment targeted the hypolimnion phosphorus, so before turnover. So basically, when you have a stratified lake and you have the thermocline, there's a density difference. So there's no mixing going on between those. So generally, where there's less oxygen, which is low in the water column, as it's depleted over the summer, there will be also phosphorus trapped in there. So 2020, we did 57,000 pounds, and then June, we did 20,000 pounds, and then June 2021, 25,000 and 15,000.
All right, here's a graph of the Secchi depth. So there's a thing called a Secchi disk, and you basically drop it down to see how far you can see it to analyze water clarity. And this is what the historical on the left here. It was less than 4 feet of Secchi depth, which is not very good. And then 1 year post-treatment, we already saw a 3-time improvement. It was already up to about 12 foot. And then we did a second treatment and it was up to 4 times improvement, basically 14, 15 feet of water clarity that was proved that you could see down with the Secchi disk.
Yep, so here we can see our phosphorus sampling at Kitsap Lake, basically 2020 and 2021. The green giant mountain on the other side of the graph is the phosphorus throughout the season. And that year in 2021, it is the other one. As you can see, these 2 high points are probably fall and spring turnover, and but it's greatly reduced. It's basically the takeaway from this.
So basically, we have improved the water clarity in this lake so much that the aquatic plant communities are thriving because they have more photosynthesis opportunities because the water is clear. So they're actually having to do some aquatic plant harvesting and herbicide treatments to maintain these beneficial uses. But basically, in summary, it helped reduce the amount of algae blooms because we captured a lot of the phosphorus that was in the lake. Here's the pre-treatment photo, 2019. And then here's 2 years after several rounds of treatment. You know, the water looks actually pristine. All right, we just spit a lot of information. Can do some questions, and also you can feel free to contact us if you have any other questions or just catch us around. Yeah, thanks for letting us present.
I'm just curious on Thunder River convention. What are the top?
What are the actives? What are we using for context? Aquathol diquat mix, and then there's another thing that we put in there.
Slow down a little bit. What is it again?
Aquathol and diquat. Yep, Aquathol K and diquat, and then there's another one, but that's our secret. Yep.
Is there evidence for resistance to ProcellaCOR?
Not yet, because it's not been around long enough, but I bet in 40 years from now, we could see that, but I think we're probably good for another 20 because it hasn't been around long enough. We saw 2,4-D resistance in milfoil after about 30 to 40 years of use. So I would imagine somewhere around then, it'll start being resistant again, and we'll just have to make something else. Yep. So there's
no restriction.
Yeah, there's no drinking water restriction. There's no swimming restriction. The only thing is a 24-hour turf and ornamental irrigation restriction. So if you were watering, ornamental plants in your garden, 24 hours, you can't do that. But yeah, it's just also, they just do that because they can't test it on every ornamental plant and see. It probably doesn't affect 90% of them, but there could be some weird orchid or something that you spray it on and it just collapses it. Yep.
Can we apply for
ProcellaCOR?
You
No.
can't apply any of these herbicides technically. You have to have an ag license with an aquatic endorsement. And in certain cases, you have to have a permit if you're treating on a water of the state.
And then also if it's a CPRO product, you have to be a dealer through CPRO, so they won't sell them to the public. You're only allowed to buy it if you're kind of, selected, because they don't want any misuse of their products, because it could be dangerous if you use it incorrectly, or if you don't use enough of it, it couldn't work and that'll make them look bad.
So, as an individual landowner along, the pretty small scale weed tree. Strips.
Yeah, like 100-foot lot or something. Yeah.
I mean, is it even practical to have
We do it all the time. We come and do personal treatments. We do a lot at Riverbend, and they like to all kind of get together and they pool their money together so we can just treat continuously down the shoreline, all the lots they're touching. And the bigger area you do, the more effective it's going to be. And also it's going to decrease our mobilization costs we have to do, because to drive out there for one treatment, you got to charge money to get out there. But if you have 50 of them all together, you can kind of take it easier on the client.
So mention that you really couldn't come up with cost. I mean,
I can. Yeah. I could say if it was an individual lot and I just had to show up there and treat just you, probably $400 or $500. And then if you had 5 to 10 people together, you could probably get the cost down to $200 or $300. But the more people that are abutting properties together is going to be, the cheaper we can get it. But I would say $400 to $500 for one lot. Yep.
So is ProcellaCOR used on grade?
I mean, not by
so many
private clients.
plants.
I mean, with the federal for the Army Corps, we do research with them. But it's everybody that's a client of ours on the Ponderay River. If you went with ProcellaCOR, it would kill the milfoil, and there would still be sago, pondweed, clasping leaf, and they'd be like, "Oh, it didn't work." It's like you need something that's non-selective, that's just going to do everything.
Sounds like as a landowner, I can't apply herbicide myself.
Unless you get a license.
But it's probably not gonna happen.
Yep.
So it doesn't really matter, I guess, for me to ask, well, gee, what specific granular app, is this? It doesn't really matter. But what matters to me is I would hire outfits such as yourself, you would treat it with the appropriate.
Yeah, no problem.
Cost me $400 to $500.
Yep. We'll put you on the list.
Most interested.
Perfect.
Regarding that, would that be a selective, like $500 for a particular selective treatment? It's just for milfoil, for example.
It would just be a general noxious weed treatment. So And it would kill all, it would basically just kill all the plants and it would kill it back for the year. You'd have to deal with it again next year, but it'll just chemically mow everything that's out there. Because chances are you have a lot of different kinds of species, native and invasive.
Thanks for answering questions. I'm just gonna talk to the online people for a second. I'm gonna launch some polls for you online folks, because I forgot to do one this morning, and then we've got one for here. So it'll be like 6
So,
questions. So
It really depends
tuned.
on how much the river's flowing. So, you know, we've treated in late July before on a really like strong runoff year. Really, we got the river needs to be calm. If the river's flowing, it's gonna wash all the herbicide downriver before it can work on the plants. You know, we need 24 hours of contact exposure time. So this year we were able to pull it off in late June because the river was at a low enough level and not flowing enough to do it. So it just kind of depends year to year. But basically we try to do it late June through middle or late July, sometime in that time frame.
Doesn't get flow until river top.
Okay.
So that's something you.
I mean, if the river, if it's calm,
It doesn't get up into a flow in front of our place until
you can treat it anytime then.
down there in May.
Yeah, you,
Flow, so you kind of get ahead of it.
and we want to see full growth. If we're doing contact herbicides, we want to see full growth because we want to just get the biggest kill that we can get. So I recommend probably June is the earliest you want to treat it. You want to wait till everything's grown up.
Whoever. You first. Yeah.
Yeah, do you know of any studies that compares like mechanical harvesting versus herbicide?
Yeah, I mean, there's some, but I mean, so basically mechanical harvesting has a purpose and tool, but as far as large scale management, milfoil propagates by fragmentation. So every time you go in and you chop all the milfoil up, somebody downstream is just going to get way more growth. So if it's a plant that doesn't propagate by fragmentation, you could probably get large scale control with mechanical, but for milfoil,
We're on the pond array and our like 6 neighbors, we all just had mechanical harvesting done.
and is
Well,
it,
there's a place for mechanical
Like a
harvesting.
giant shop vac.
oh, it's dash, it's dive,
And they're sucking it.
it's dash.
There's a place for that. It might probably do a better job if you get it dashed because they're going to get every single plant down there. It's just going to cost 2 or 3 times as much. But if you want a solid, clear bed, then dash might be the way you want to go for it because
Yeah, and
it's
dash,
going to get everything there.
also we'll explain dash, but dash is what they're doing. It's diver assisted suction harvesting. Yep. Cool. You got one? Yep. Diver assisted suction harvesting. So it's basically you take a giant pump and you pump the water and suck all the plants off the bottom into a conveyor belt in a boat. And then usually they just dump it in the middle of the river and it gets stuck on somebody's dock like 10 feet down. Yep.
Doing chemical control will control about 70 or 80% of the plants. It's not going to get all of them because the river is flowing. So it's not going to get all of them. Doing dash, it will really ensure that you get every single plant. It's just going to cost 2 or 3 times as much. So.
We good? Okay, cool. Thanks.
Thank you.